Welcome back to the Hyperbolic Coding Chamber. Today we are celebrating 200 days of coding the leets, and who would have thought that on day 200 we would receive correspondence from the LeetCode developers at LeetCode LLC. So we have received breaking news. They have corresponded with us. I was in the VC last night with some of the top tech executives across the planet, and as well as all the people at Discord. And as I was in the VC, I received some communication in the form of an email. I thought when I opened this email, I would be offered half of half of LeetCode LLC, but it was something even better. So I'm gonna switch screen. I'm gonna take a quick look at it. Let's switch to this screen. Oh, brother, it takes forever to upload. Okay, so we're good now. In the correspondence we received, note: congratulations, you have won the 100 days badge of LeetCode, and apparently we solved problems for more than 100 days in 2022, which is kind of improbable because, oh wait, no wait, we've done 200 days, so we should have got the 200. Yeah, you know what, this is going to turn into a rant video. We should have got the 200 days badge. So this I actually don't know why, but it's probably because of the way the check-in system works. Even when I check my graph, sometimes it says my longest streak is 20 days, even though we do it every day. That being the case, it was pretty cool to see this I was actually at a New Year's party, but it was pretty cool to see this hit the inbox last night at around 11. And I was like, feel strong, man, LeetCode LLC. So maybe when we reach 300 days, we'll be offered half of LeetCode LLC. That would be pretty cool. Maybe once we finish all the problems, we'll have a royalty-based revenue share. But other than that, yeah, it's been pretty cool to get to 200 days. So hopefully we have many more to come this year. When we started 200 days ago, oh man, we actually have an ad. When we started 200 days ago, I was not certain. I thought we'd be much further than where we are. That being the case, I'm still relatively I'm pretty stoked as to where we are in the journey. So I thought we'd be farther along, but I guess there's something to say about that. I thought we'd be farther along, and I thought based on how much further along I would have been, I would have felt more content about it. But it turns out I'm just as content with as far as we made it. So 200 days ago, I thought I would have to have done all the problems or have been much further than I needed to be. That would be the only way I would be satisfied. It turns out that was not the case. Turns out I would have been satisfied with any meaningful progress from where I was at the time. So maybe there's a lesson in there somewhere that sometimes what we really just need is to start. That being the case, we have some new goals for this year. So it's day 200, but at the end of this year, I say we should have completed all of the easies and all of the mediums. Shall we? Need I say more? Shall we? Would it be possible? I think by the end of this year, that'll have been end of next year, that'll have been day 500. We should have solved all the easies and all the mediums. And yeah, at that point, we should have done that. So if we haven't done that, need I say it, if we haven't solved all the mediums and all the, actually there's 1,300 mediums. If we haven't solved all the easies and the mediums, we will shut the channel down and we will submit all of our assets over to LeetCode LLC, and we just have to submit our assets onto them. So it is what it is. That being the case, the second thing I was going to talk about was maybe like a talking to a past version of myself. How does one get to 200 days, even though it's not really that great of an accomplishment? I think the cheat code, we have a legendary comment by Wilderness in the Discord that pretty much sums this up in about 3 paragraphs. So if you're interested, you should definitely join the Discord to find out that answer. But that is the way to get to 200 days. Basically, whether it's LeetCode or it's something else, everyone struggles with something different. So you might see someone who doesn't struggle with doing LeetCode every day, but they struggle with something else. Like maybe they want to write, maybe they want to draw, maybe they want to work on claymation, maybe they want to work on Arduinos, maybe they want to practice League, who knows? But they struggle with doing the thing they actually want to do. That being the case, I think the way to get there is to return to baseline. So basically go monk mode, and you have to reduce the environmental dopamine abuse. That's the only way that has worked for me. I think sometimes when I tell people how much, sometimes when I say how much restrictions I have and everything in my household, it sounds a little crazy. But I have 3 computers. This computer has a cold turkey blocker on it, which basically means I can't access any sites besides LeetCode and a couple of other websites. I can access like pretty much any other website except any top 50 social media site I can't access. I can access studio.youtube.com, but only that domain. I have another computer, which is a Windows computer, and that computer automatically locks at 12, so I can't stay up late to mess up my sleep schedule, which messes up the grind for the next day. I'm just now figuring out this whole thing was more about the environment than it was about the thing itself. So that has been working recently. I've been able to show up this past week, and we've been doing the same time as we usually do, but the weeks before they were really difficult. And that's because I was basically just binging dopamine in every facet, in every form, which made the grind harder. So that being the case, it doesn't mean you can't have any fun. It just means it should probably be structured and intentional, at least in my case. So that's kind of what's been working for me. So I'm going to try and turn the dials on those up and optimize that instead. And hopefully things will turn for better. So that's going to be the new optimization vector, and we shall see if it works. It's already working. So I had a week off this week, and I plan to do a lot more. And I mostly just spent time resetting. So I just mostly read the whole time. I didn't really watch. I think the most amount of YouTube I watched was like an hour. So that would be the goal. That would be another goal. I would say I want to try and squeeze more out of the day, and I think to do that I'm going to have to turn a couple more dials down. It'll be a simpler existence, but hopefully at the end, once we own half of LeetCode LLC, we'll be able to stop and turn all the binge factors back up to 1,000. So that's pretty much where we're at. And also, yeah, it's been a pretty cool year. So hopefully next year will be pretty cool as well. Who knows? Maybe we'll have maybe our progress will exponentiate so quickly that we'll have solved all the problems that we needed to by the end of this year. That would be pretty cool. But who actually knows? I might be dead. So we shall see. If I die, though, the channel will be lotteried off to the next LeetCode person, and they must pass the torch one for all style. And then, yeah, we'll just keep going until the end of time. So that being the case, we do have some comments that I failed to get to last time. So we're going to look at those comments.
I've been getting paid $1,000 a month, if not more.
We're getting so many ads today. I'm not exactly certain why. So we're back now. Keep up the great. So we have the online gamer, or the onion gamer. I think it's the online gamer in Leet speak. Keep up the great work. You too, big brother. And then we have Omega Chad, which looks like with a profile picture, which looks like it could have been modified by Lensa.ai. We're not certain. How can I start to do competitive programming? I completed basics of C++. Should I complete DSA first? That is a good question. I think we're mostly. I think the general consensus, and I'm not certain here, is that LeetCode is more for practicing interview style questions, and then you want websites like Codeforces or @Coder or I think CodeChef for more competitive programming based things. They also have resources like USACO and stuff like that. I've completed the basic C++, which is pretty cool. I guess it depends on your programming experience. Should I complete DSA first? Probably. I don't think there's an optimal order. Maybe the order that allows you to keep going is probably the best. So if you feel like you're primed to do DSA, that could be the optimal route. But I definitely don't know a lot about competitive programming. But I would recommend Colin Galen's channel. He is a beastion at this stuff. But I think LeetCode is probably easier than competitive programming. It might be a good place to start, or I think competitive programming may also have more math puzzles, but don't quote me on this because I'm not exactly certain. But the LeetCode Explorer cards are good introductions. But I don't know how much experience you have. If you have no experience at all with these problems, maybe you could start from like Elo 0 at one of those competitive programming websites, or you could start with Explorer cards on LeetCode to dip your feet in. But either way, both paths will be hard. So I think there's definitely better resources for competitive programming. Maybe we'll do some CP after this because we'll have to do something once we run out of problems. Or maybe we'll just keep doing random problems in the weekly competition and whatnot. So that remains to be the case. And yeah, also I would say yeah, thanks to everyone who joined the Discord this year, and thanks for all the people who joined the channel. So hopefully we can keep having part-time authors, entrepreneurs, artists, musicians, claymation people, computer touchers, and all continue to join the Discord, and we'll just continue to pass around some philosophy. And we'll have talks. Our next upcoming talk will be by 21 Savage. He's going to be giving us he's going to be in the VC this Friday, so you definitely want to join for that. And then, yeah, if you're interested in something like this, you should join the Hyperbolic Coding Chamber, which is in the link in the description below. That being the case, I guess there's not much left to say but to begin the grind. The grind of the struggle sounds to... We must begin the work. Also, yeah. So that's where we're at, and I think we'll just jump into it for today. We're making good progress, so let us keep at it. So I think we have completed so far I think we spent yesterday doing a relatively difficult problem, or it was one that made us think. I hadn't had to think like that in a little bit, so that was interesting. Oh yeah, it was called DI string matching, and it was pretty fun. And we ended up overcomplicating a little bit, but we were able to get it in the end. So hopefully we can keep working at it. Now we're back. Oh yeah, we were working on kth largest element in a stream. So this seems more like a design question. But we have to design a class to find the kth largest element in a stream. Note that it is the kth largest element in the sorted order. Note that is the kth largest element in the sorted order, not the kth distinct element. It pretty much has to implement a class where the constructor initializes the object with integer k and the stream of integers nums, and then int add, which takes a value and appends the integer value to the stream and returns the element representing the kth largest element in the stream. So it seems like we basically have this function here, and we guess we can choose a vector of optimization. I think we were thinking about this. There's definitely not, I don't think there's a way to do this in linear time, but I think if we knew how to implement a heap, you could do it in log event time. Maybe. I don't know. I don't know for a heap, the time complexity for adding. Isn't there like a rebalancing part? So I don't actually know how long that would take, but if I guess we're working under the assumption that add is going to be called a lot. If add takes n log n, if we call it n times, it would pretty much be n log n squared, which kind of sucks. And I guess we'll see, it seems like we can just do that, but definitely would not be ideal. So, and we'll just say k, which is a number, is equal to 0 to start, and we'll just say this dot k equals k. This dot nums equals nums. And we can just say nums dot sort AB. It doesn't really matter if you sort it in ascending or descending order, but let's just sort it in descending order. And then what we would return would actually be this dot nums sub this dot k. Let's just make sure we make that make sense first. We have to add this dot nums dot add dot push. So let's just say we have 8 elements. Let's say we have 5 elements, right? We added 1 with this add function. Now we have 6 elements, right? We want to return, let's just say that k equals 2. We'd like to return the kth largest number. So given, let's just say an array that was sorted something like this, 5, 4, 3, 2, and then 0. The second largest element would be 4. If we do this, if this dot num sub k, we would actually get 0, 1, 2, which would be 3. So probably minus 1. But I'm sure this would pass, but it's more of a design question, I think, right? Or maybe, oh no, I was gonna say maybe there's a really hard time complexity. N log n squared is trash. I feel like with a heap you could do much better, or there's no natural implementation of a heap in TypeScript. We should learn how to create a heap. Maybe that's what we should spend today doing. Right, so they have heap, tree. Oh, wait. You could also have used a binary search tree. Insertion into a binary search tree. Insertion into a binary search tree. Most probably takes log n. Well, insertion into a binary search tree. Insertion into a binary search tree. BST, I'm pretty sure to find what you're looking for takes log of n time. But I'm not certain. I don't know. I'm pretty sure that's what it takes in a heap. But is a heap just a BST? Now that I'm thinking about it. Is a heap just a BST, bro? Fundamental distinction is that whereas the binary search tree does not allow duplicates, what do this mean? I don't understand the difference between a BST and a heap. Maybe we should go through the explore cards. If we had a BST, I feel like we could make this make sense. Because if we had a BST, we could search in linear, or insert would take log of n time. We could also find the number in log of n time. Mean that adding would take log of n time. If we had to add n times, we would get n log n, which is much better than n log n. Wait. Sorting takes n log n time. Oh yeah, for one call. This would take n log n squared. If we use the binary search, it would take log n time. If we added n times in a row, it would in general take n log n. N log n is definitely better than n log n squared. So what if we had class like a node and it had a value, should be a number, and it would have a left, right, which could also be a node, or null, which would be equal to null. And then it would have a constructor, which would take a value, right? We'll just call this a B node, because I'm pretty sure the namespace is already polluted, I think, with LeetCode's own stuff. So if we had a B node, and then we could create some methods, we could create some functional methods like insert. This would take a root binary node, and a value, which is a number, and it would insert it into the binary tree. And then we could test for correctness, because if we do an in-order traversal of a binary search of a BST, we should get an array sorted in ascending order. So another function we create is print, take a root B node, or null, it's going to do void, and we're just going to say, or we'll just call it node. If node, right, then we're going to do print node, right, before that we'll do, my bad, print of node dot left, right, then we're gonna do console.log node.val, and we can copy this and do node dot right. Then to test, we can just return 0 down here. We're never going to get it wrong, but it's just a test. Actually, we can do it in here. Root equals new B node. What we'll include in the binary node is a value that's going to start at 100, and then we'll call insert root 50 but how would you find the largest element in a BST? The largest element, it's only log, wait a second. Oh, the largest element would be going right as far as we can. Wait a second, but n could be, k can be up to 10 to the 4. So how could you actually even use a BST here? Actually, it would be better, because you could do it in, so if we use the BST, we load all the values in. On insert, it would take log n to insert, then linear time. Let's just think about insertion. I think I'm thinking about it and doing n. If we do sort, then add takes n log n time. Do a BST, right? Insertion takes log of n time plus linear time, which would be better than sorting. And the heap would obviously be the best, because it would just take log of n time. So the goal with the heap in the end, with the BST in the end, would be that we don't have to sort it. We can just do an in-order traversal. Or actually, we could do something. We could just do a post-order traversal, which would give us the array sorted in ascending order, and we would just count up, and whenever k equals k, then we would know. So let's finish writing our test here. We have 99, 48, and I'm gonna add 1 here, and we can do print root. And then we actually need to implement insertion. So when you insert into a BST, I'm pretty sure the node at the top is the starting value. Oh, it has to be balanced correctly, right? I think. Worst case being if the values added into the BST are chained, then we end up with insertion taking linear time. Which would still be 2n, which would still be better than n log n. So to insert, we have the root node, and we'll just change this to node. What gets passed in the first time would just be the root node. If, let's just say 100 is at the top, we want to insert the test 99. I think the BST is that the left node child is less than wait a second. Can a BST have duplicate nodes? I think it can be less than or equal to. Can a BST have duplicates are not allowed? But they said you could use a BST here. How are it's possible to use a BST here? I think we can make it support. I think we can force it to support duplicate elements. We'll have a variable called extras. If we have a duplicate node, right, then we'll increment extras. Then when we're iterating through, for example, when we print it, we'll say if node and then we'll print the extras. And then you can say, right, if you want to insert, right, so we're going to say if node dot val equals val, right, then we're just going to say node dot extras plus equal 1. And this is just a test. If we click run, we do get two 100s, so that kind of does work. And then going forward, we want to say else if, right, node dot val is less than val. So if we have 100, if we have 99, right, we'll say is 100 less than 99. Actually, it'd be easier to do it this way. If val is less than node.val. So if 99 is less, if 99 is less than the node, right, then it should go left. So they insert node.left val. Else if val is greater than it, insert it except go right. But maybe it's not that simple though. So if we have a tree that has like 100 and then we have 99, we want to insert 88. We need to say something like node.left equals new b node. So 99 is less than 100. We insert, and then we'd say, okay, is 99? Is 99 is less than 100. So if val is less than 100, right, then we have two cases, I guess. Either the node exists or we have to keep going deep. Either the node doesn't exist or we have to keep going deeper. If not node dot left, right, then we want to say node dot left would be equal to new b node val I think this makes sense. So if we had to insert 100, right? Which we do, we do 100, we insert 100, we insert 99. Okay, so we call insert with root and 99. If the val 99 is less than 100, so that's true, but node.left doesn't exist, so we're gonna say node.left equals 99, and then we'll stop. Then we want to insert 1. Okay, we'll start back at the root. Is 1 less than 100? It is, so we do insert node.left at, now we're at 99. So now is 1 less than 99? It is. Based on this, and then 99's left doesn't exist, so we'll add a 1 there. Now let's say we want to add 48. Let's say we want to add, 48. Oh no, this is too simple. So we want to add 48. Go left of 100, left of 99, Left of 99. 48 would have to go between 40 would have to go between 1 and 9. Indeed 9. Every node in the left subtree should be less than the node, so every node 48 should be to the left of 99. So if the node doesn't exist, right, we insert it. Now what if the node, now we add another else if node.left and node.left.val is, so let's just say we have like 100 and we have 99 and 1, right? Node.left exists, which is 1, and node.left.val is less than val, then this is where we would do that, I guess, that replacing portion. Node.left and node.left.val. The left is 1. 1 is less than 48. One's less than 48. One does not make any sense though. If we had 1, let's just say we added 48. That means to the right of 1 would be 48. Yeah, this version would make it break itself. How do they even guarantee that this makes sense in VST? Every node's left child should be less than its right child, and every node's left child should be less than the node itself. And then every node's right child should be greater than the node itself. if we have something like this here, based on this order, it should go 100. This is a mess. This would look something like 99 would go here, 1 would go here, and then 48 would have to go here. Now if I wanted to insert something like 49, I would have to insert it above the 1 here. But if I put 52, I would also at the same time, even if I had done there's no way my implementation of the BST makes sense, because even if you were to do this in order, if you were to print this tree in order, in order traversal, left, 1, right, you actually would get 48 and 99. Okay, so if I wanted to insert something like 50, I would say, well, no, actually before then, if I wanted to insert 48 with this current style, the left node exists and node.left.val is less than 48. You shouldn't, I think I understand. You shouldn't put it below it. This shouldn't even exist, I think is what I'm getting at. What should happen is I should shove this down further. You have 99. I should put 48 here between them, and then I would get 1. This looks much better. Then if I ever get 58, I can insert it between them. So you pretty much have to replace what already, you pretty much have to insert it in between there. So we have a node that we're currently at. We want to place, we want to create a new node to be the new left, while also not breaking the tree. Do that, since the tree is pretty much only pointing downwards, we can just save a reference to node.left. And then say node.left will be equal to a new B node, which would get the value here, and its left node would actually point to temp. Its left, the new node we're inserting here, its left node, the new one we're inserting here at 48, its left node would be equal to temp, which is 1. I don't think we should have to do anything with the right node. It's the node itself, 48. We're replacing its left node, so we're going to save the temp value that's at 1, create a new node where the value is 48, and then set the left node's value equal to the new node's left node value, the new node's left pointer value to the node that used to be there. And then we should be able to just duplicate this here. Node.right, and since we're going right, we're trying to insert right hand style. Node.right.val is greater than val. So what that looks like is 1. Let's say you want to insert if we have 100, then we have like 150, and then we want to insert 125. It would just go left, actually. If we wanted to insert 175, we'd say if node.right.val val is greater than node.right.val. And here you could change this to if val I'm getting confused. If val, which is 48, is greater than the left hand value here, we have 99 and 1. When do we insert 48 here? When 48 is greater, is less than the number and greater than the value below it. Let's see if it could insert 99 correctly. So we had 100, 100. We'd have 2 fake nodes at 100, and we should pretty much just be testing it. If the node doesn't exist, which is left, we should create a new node. So we get 99, 100, 100. So that seems to be working. Now, if we add a 1 here, we should add one more node to the left of 99. Get 1, 99, 100. Now if we add 48 here, we should be testing the code. We should be testing the code here where node.left exists, which should be 1. And also so val, which is 48, would be greater than 1. So we get 48. Now we just need to test the same thing, but for the other side. So here we could add 150 and then 140. It should go to the left of 150, and then after this whole thing, if we add 175, the replacing portion of the logic for the right hand side should also be right. And so this is where we realize this version doesn't exactly work. So 175 is not in the correct place. Or it is in the right place, but since it's greater than the number, its temp node should still also, the one that we replace at that position should also be put to the left of it, because it is left of it. Okay. So the final thing we should have to do, I'm gonna pretty much comment all this stuff out. We could just say this dot root is equal to a new b node, or it's equal to null. Then we'll create a property called root, which can either be a b node or null, and it's going to start at the value null. And we're going to say if root then oh no, wait, I forgot. It's given a number. It's given a list of numbers to start. So we'll say for num of nums, right? Insert root. Let's say this dot root. I should make sure nums can't be empty. Nums.length can be empty. Since it can be empty, we shall say this dot root is equal to null, right? But if nums.length is not equal to 0, right, then this dot root start with the basic value of a b node, which of num sub 0. Then we'll do for let I is equal to 1, I is less than nums.length, I plus plus. We insert root num sub I. Then we'll do the same thing here. We'll say if the root doesn't exist, right, in case nums.length is empty, right, we'll just say this dot root is equal to new b node with val. And then hopefully this was not all for naught. Now we just have to find the kth largest element. To do that, we'll copy our print function, which is just going to do a post order traversal. We'll just call it find. We'll pass in we'll pass in object by reference with a property that's a number, and we'll pass it k, and we'll say find of node dot right with O with k plus 1. Oh no, not with k plus 1. With k. Here we'll say O dot cur plus equals 1. I don't know how to do the early return version. So actually, maybe we'll just literally keep things. For some reason, early return always gets me when doing DFS, but we'll just keep. Call this build. We'll take a B node, an array. Wait, what happened to the rest of the function? An array of numbers. Instead of printing, what we're actually just going to do is say r.push node.val, and then we'll do the same thing in here. And then instead of print, we'll just call build. This is just going to give us the array and sorted in ascending order. And then, in fact, we can just do it like this to get it in descending order. And then we can just say const r is equal to build this dot root. Or I guess we can do it like this. Oh wait, I forgot to. right? And then otherwise we want to call it insert with this dot root and val. Okay, this thing, the time complexity on this is absolutely awful. I actually don't know why. Our sorting solution took 3 seconds. This other version takes 5,000 seconds. And I wonder if we remove the console log. Maybe the balls part is that our tree is not balanced. It could be that what's happening is this else case, which I'm inserting, is adding more time. This is still the same time. Let me test something actually. If I remove all this add stuff, and I end up just copying R. In fact, I'll just uncomment this one. Then I'll say for const num of this.nums.push val, say r.push nums, and then we end up sorting the array, and I want to see if it's just as slow as the other one, because it could be the linear time iteration that we skip. Let me uncomment the work we did up here. I copy this whole thing as a test case. do date. Let's just do some timing real quick. As soon as insert is done, we'll say that end equals date.now. We'll say insert is equal to end minus start. Insert time, and we'll say build time, which we'll put here as start, so we know how long the build time took. Oh, I forgot this runs. Yeah, I forgot. Yeah, I think my page just went. My page just died. So I think we'll stop there.